Hello again, class. So this is actually just a continuation of introduction to reaction mechanism, wherein we will talk about the last part of it, which is the energy diagram. So by energy diagram, we will actually talk about the changes in potential energy within our substrate. By substrate, as we have the when you talk about substrate in organic chemistry, it is our organic compound. So, in this diagrams, we will actually uh, show how the energy changes during the reaction. So, the energy changes that take place during a reaction is clearly changing depending on what type of reagent we have, depending on what substrate we have, and the products itself. So basically, when we talk about energy diagrams, we have different types of energy diagrams, wherein it can be a one-step or called concerted or yung tinatawag nating hypothetical reaction. And in some cases, it can be a two-step, three-step, and so on, depending on the type of substrate and reagent we have producing different kinds of products. So first things first, let's say we have a reaction wherein we have, say, say we have a reaction between a substrate A plus a reagent B that produces a product D plus E. So as we can see here, this is actually a one-step chemical reaction. By one step, the reaction only goes or the reaction just have one process in some sort. So in consideration of reactions, there is actually one state in which we considered it as the important part of the reaction. So basically, it is just a graph or a graph of change of potential energy as the reaction progresses. So basically, one illustration or diagram that we can derive from this is if we start from our reactants, which is A plus B, this is our reagents or reactants. Say the potential energy of our reagent start from here. It start from here, then it goes up, then suddenly the potential energy will go down like this, and it will become constant. Okay, so there are actually three main parts of this energy diagram: the part where it is constant, the part where it starts, and the part where it peaks. Okay. So we have here these three parts. So this is our reactant stage, and this will be the part where we have what we call the transition state or TS. Then we have here the potential energy of our product. Okay. So in this actually, as we can, baga sa Tagalog, parang ganito siya, ano, uh, having our reagents or kung meron tayong reagents, tapos yung reagent ay nag-undergo sa isang energy change wherein yung potential energy niya ay tumaas up to a certain peak or sa maximum at sa maximum, then it will go down. This part, transition state, ay dito actually nag start yung tinatawag nating dito yung start of reaction. Okay. Ibig sabihin, before pa man tayo magkaroon nung partial tawag dito, partial reaction or partial na reaction ng A at B para ma-produce yung ating D and E, kailangan munang ma-reach yung potential energy nito. So basically, kapag meron tayong ganitong type ng reaction, so halimbawa, lagyan ko ng ano ito, ng line. Itong line na to, wherein yung katapat ng ating yung or yung level nung kung ano yung potential energy ng reagents natin, and we get the distance or the difference between the transition state or yung peak, yung part na yan, yung difference dyan sa energy na yan ay yung tinatawag natin na energy activation. So, ito lang ha. Energy activation. Meaning, or energy of activation, sorry. Energy of activation. This energy of activation is actually the required energy or the amount of energy that is required to start the reaction. Meaning to say, at this part of the reaction, let's say from the transition state, when the energy of activation is reached, dun pa lang tayo magkakaroon ng partial na bond making or bond breaking. Dun pa lang talaga magsisimula na halimbawa kung ang reaction natin ay addition reaction. Halimbawa, addition reaction kanina sa ethene, nag-add tayo ng ng halogen. Ah, Diyan pa lang magkakaroon ng tinatawag nating mabe-break yung double bond or magbe-break or magkakaroon tayo ng bond cleavage nung halogen natin. Tapos saka pa lang tayo magkakaroon din ng bond making diyan. Kumbaga, yung halimbawa, yung halogen sa halo siya ron sa ating ethene or mag-a-attach siya ron sa carbon dun sa ethene natin to produce our our halides or yung tinatawag nating organohalides. Okay, so in here actually we can see here that there is also a difference between the potential energy between our reactants and the potential energy of our product. Okay? This difference is actually what we call our enthalpy or yung tinatawag na delta H. So ano ba yung tinatawag na enthalpy? Enthalpy actually is just the change of energy in the system of our reagent and our product. So for this scenario, as you can see here, we actually have a negative enthalpy. So by negative enthalpy, ibig sabihin, yung energy na meron dun sa reactants natin ay na-release sa environment or na-release outside dun sa substrate natin. Meaning to say, we have less energy from this point on, from our reactants to our product. Meaning to say, we have here a negative enthalpy. And for this scenario that we have a negative enthalpy wherein the potential energy from the reactant is higher than the product, or the product contains less energy or potential energy from the reactant, this is actually what we call exothermic reaction. Exo means outside, thermic means heat. Sabihin, heat is released. Okay. So, ano yung itsura ng isa pa? So, by isa pa, yung tinatawag nating paloob naman yung pasok ng potential energy or energy is taken from the environment towards our substrate. So, let us illustrate that. So, for our energy that comes from the environment to our substrate, the reaction energy diagram would look like this. In a second. So, we will have here a graph wherein if this is our uh, reactant, our product, or the potential energy of our product will uh, be on this level. So if we have the same scenario, if we have A plus B which produce D plus E, what happened here is we have here our reactant, this is our product, this is our TS, okay? So as you can see here, what happened here is this is our the level of the potential energy of our reactant, and this is the energy level of our product. As we can see here, there is actually an increase in our H, or yung ating enthalpy. Meaning to say, we have here a positive enthalpy. Ibig sabihin, from the environment or from kung saan man, from anong condition, our substrate absorbed potential energy potential energy. So there is an increase in heat or energy in our substrate, meaning to say this reaction or this type of energy diagram is actually what we call an endothermic reaction. So endo means inside, thermic means heat. So the energy goes inwards the substrate. Okay. So same concept with the TS, mapa endothermic or mapa exothermic. We have here this energy activation, which is from our reactant or the amount of energy or change of in potential energy to the TS or transition state to our potential energy on the reactant. This is actually our EA or the energy of activation. So that is the difference between our endothermic and exothermic reaction. So there is no change regarding the transition state. We just rewrite that is our transition state. So the transition state is where our partial bond breaking and bond bond making will happen. Okay. So in here, we have here a positive enthalpy. That means this is endothermic reaction. Okay. So you may have heard of what we call catalyst. Okay. So ano ba nangyayari kapag meron tayong catalyst? So basically, when we talk about catalyst, those catalysts actually speed up the reaction. So in addition of the catalyst, what happens is if we still have this endothermic reaction, if we added a catalyst here, let's say we have here our F, which is our catalyst. What happens is if we have this potential energy from our reactant, the energy activation actually lowers or bumababa yung tinatawag nating uh, energy activation, meaning mas kokonti yung energy na kailangan natin para mag-proceed yung reaction. So ganun yung ginagawa ng ating catalyst. So meaning to say, this blue line is our EA whenever we have RF, which is our catalyst. Okay? So that is how we look into reaction energy diagrams, which in this case is a one-step uh, energy diagram. So, as you can see here, actually, forward yung tinatawag nating reaction dito. Paano forward? From our reactant, our original substrate, magkakaroon tayo ng DE. So, in that, we have this energy activation or energy of activation. So actually, this energy of activation is what we call the energy of forward reaction, energy activation of forward reaction. So kung babalik natin yung reaction, say we have DE, ibabalik natin siya sa pagiging AB, pwede pa rin natin yung makita dito sa ating dito sa graph natin ito. So basically, what we can do here is look into our product. So in our product, that that level of energy or potential energy from the product towards our what we call our transition state. Let me write this as green. So that difference in the potential energy is actually what we call our energy of activation, which is reverse. So, meaning to say, the difference between the product and the transition state of our energy diagram will be the energy required para baliktarin yung reaction natin. So, we have here our energy activation, which is forward, and our energy activation, which is reverse. Same goes with our exothermic reaction. Ganun lang din gagawin natin. We just need to account for the difference between the potential energy of our transition state and our product to get the energy required to reverse the reaction. Okay, so in that, let's put some numbers here. So para lang dun sa ano natin, computation, just in case na kailanganin. This is just an estimation, wala, hindi masyado talagang ano ta. But anyway, say we have here our the potential energy of our reactant is, let me just change the color to blue or dark blue. So we have here our energy of our potential energy of our reactant is 100. The energy of our potential energy of our product is, say, let this be 200. So, and our TS or transition state is 450. So, halimbawa, yun yung binigay sa atin. And we are to get, or tinanong tayo, what will be our energy of activation for the forward reaction. So in this, ang gagawin lang natin actually is you just need to look at the TS. That will be the RTS. So that is TS minus the energy or the potential energy of our reactant, which is 100. So our energy of activation for forward reaction will be 450 minus 100. So we will have here an energy activation which is 350. Ibig sabihin, we need to add a unit of 350 units of energy on our reactants uh, for the reactions to move forward. So how about our energy of reverse reaction? So that will be just the TS minus the energy of the product. Alright? So we will have here 450 minus our 200. So we will have here an energy which is 250. So meaning to say, to given the product which is DE, and we need to reverse the reaction into AP, we just need 250 units of energy for the reaction to reverse. So basically, using this, we can actually get our delta H. So for delta H is just the energy activation forward minus the energy activation for our reverse reaction. So we will have here our 350 minus our 250. So meaning to say we have here 100. So we have an enthalpy which is 100. Or there is, as you can see here, there is a positive value for our enthalpy. So actually, there is another way in which we can compute for the enthalpy. So delta H is just equal to our the energy of our product minus the energy of our, or the potential energy of our reactants. As you can see here, we have here 200 minus 100, which is equal to 100. As you can see here, both of those computations are equal. Okay, so that is our one-step uh, reaction energy diagram. All right. So how about what we call a two-step energy diagram? I'm just checking whether I am recording. But anyway, let's go to our two-step energy diagram. By two-step energy diagram, if we write that using if we write that using chemical reaction or chemical equation, it can be written like this. Just change the color of my pen. So that will be if we have A plus B and that reacted and became C, then that C became B plus E. This is what we call a two-step energy diagram because we have two arrows wherein magkaroon tayo ng dalawang step. So basically, paano ba natin ipapakita to? Or paano natin ipapakita yung ganitong reaction? So, kung nai-imagine nyo, kung ito ulit ang ating potential energy, ito ulit ang progress ng reaction, we will have here dalawang transition states. So, meaning to say, it can look like this. We have here that, and another peak, which is that, and it will be constant. So that is how a two-step reaction may look like. So as you can see here, we have here two phases for our reaction. So basically, here is our A plus B, here is our C, and this is where we can find our D plus E. So how do we look about this? So, kung titingnan natin to actually class, meron tayong dalawang transition states dito. We have TS1 and we have TS2. Meaning to say, uh, according to this energy diagram, from this potential energy of A plus B of our reactants and our substrate, we will need this much energy. So let me just So we will require this much energy before our A and B bonded or react to each other to form what we call our C. Okay? Or yung tinatawag nating this will be our intermediate. Ito muna bago tayo naging D plus E. So, and this one or this TS1 or the difference between the TS1 and the potential energy of our initial substrate and reactant is actually we call the first energy activation. So, and also, if we account for the energy level of C, we have here a delta, our first delta H, which is actually, as you can see here, is positive Meaning to say, the reaction from A plus B towards C is actually an exothermic reaction. So we have here that reaction towards our intermediate C. So from that on, from our C, we will have lesser activation energy kasi basically this will be our new reagent or new reactant. So this will be our EA2 for our of activation 2. Wherein once the system or once C receive this much energy, it will start producing our D plus E. And as you can see here, if we look into that from that potential energy and the level of this one, we can see here that we have a negative, partial negative, yung tinatawag nating, tawag dito? Yung tinatawag nating enthalpy mula sa C. And looking into this, and looking into the original potential energy and the potential energy of our product. As you can see here, again, we have here a negative enthalpy. Meaning to say, uh, from the intermediate towards our product, okay, we actually have what we call an endothermic reaction. Okay, so overall, when we look into this, if we sum up all of the enthalpies, let's say yung partial enthalpy natin na una, itong positive and then itong negative, makikita natin dito na mas malaki yung difference between our negative enthalpy and positive enthalpy. Therefore, our overall enthalpy will be negative. So that is how we look into that energy diagrams. Actually, it can also happen in other ways where in all of the reactions are exothermic, all of the reactions are endothermic, so it can happen on both ways. Okay? So here we have here exo, then endo. So if we look at it on the other way, in other ways pala. So let's say we have first this, and we have this level for our reactant. Then we go endo. Then it can happen that we will have an exo. So as you can see here, this is our reactant. We'll write this as R. This will be our intermediate, and this will be our product. And as you can see here, we have here an endo. Okay? I mean exo pala. Exo, then nag-endo tayo. Alright. So that is how you look into that. So again, this is our TS1. This is our TS2. This will be our first EA or first energy of activation. Then we will have here a greater energy of activation, which is EA2. Another concept that you might need to understand here is what we call the rate of determining step. By rate of determining step, uh, it is simply understanding or identifying which of the transition state has higher potential energy requirement or higher energy activation. So, let me just rewrite that. Rate determining step is the highest energy requirement for the reaction to proceed. So in this case, say we have here this reaction. As you can see here, TS1 or energy activation 1 is actually higher than our energy activation 2. Meaning to say, our EA1 is our rate determining step, right? Because it requires more energy for the reaction to proceed. So basically, that's it. That is our reaction energy diagrams. We have here two examples of one-step energy diagram, and also we have here two-step energy diagrams. So in that, I leave you this assignment. So if you don't watch this video until the end, you won't be having this assignment. So this is some kind of a challenge per se. So for your assignment, I would like you to construct a three-step reaction diagram wherein the second energy activation is the rate determining step. The first step is endothermic. The second step is exothermic. And the third step is endothermic. And the overall reaction is endothermic. Okay? So I will be just posting on Edmodo regarding this assignment. So good luck and have a nice day.